So I'm here to talk a bit about the wonderful world of software distribution and how I see that mattering to the Python world. But before we dive into that, I want to tell a bit of a story about where I'm coming from and my perspective on what the software distribution problem actually needs to cover. And we're actually going to go back to the last century. In 1999, World Solar Challenge, solar car race from Darwin to Adelaide. And this is University of Queensland's Sunshark solar racing team, parked off the side of the Stuart Highway for an afternoon charging session. I'm one of the folks standing around the car there. Not a lot of internet coverage in the middle of Australia, even today. And this was actually my first non-trivial programming project. A few thousand bytes of HC11 assembler to run the telemetry and motor control system in Sunshark. And so, yeah, this was kind of my real introduction to the world of collaborative software engineering. So that's mechanical engineering to build the car, electrical engineering for the solar panels, motor control, telemetry system, radio engineering. We bought some radio modems. There's a heck of a lot of stuff that goes into making something like this possible. But we live in a world where even in 1999, you could get all that stuff at university level. But there's a lot more to this than just software. But the software is what makes it go. And in a similar vein, my first occupied about 12 years of my professional career, is a thing called the High Frequency Modernization Project. And Australia's big, oceans are bigger, and satellites are really expensive, whether you're renting somebody else's or running your own. And so high frequency radio is actually still one of the best methods of long distance communication on Earth. It's not so much because it's really, really good, but because it's really, really cheap by comparison to the alternatives. And so this was a project where I did a lot of digital signal processing work. And this was the project that introduced me to Python, because C's great for actually doing your digital signal processing. It's not so great for writing your tests. And so I used Python. And Python's integration with C and with all that sort of stuff was really, really useful to us. And it became our go-to language for system orchestration tasks and making all of the other parts of the system actually play nicely together. And so it was during the decade or so that I was working on this that I got involved in C/Python core development and discovered that there was a different way of organizing software projects, that you didn't have to have these giant command and control structures where orders came down from on top that told you what to build and when to build it, but that you could actually collaborate on the internet with a bunch of people pretty much doing their own thing, but pointing in the same general direction, and actually making the software happen that was great for all of the people working together to develop it. And so I ended up leaving Boeing, whoops, and I landed at Red Hat. Now you may be wondering why I have a picture of an IBM mainframe when I'm talking about Red Hat. And so the thing I actually do at Red Hat is I'm actually an internal toolsmith. I work on a bunch of our internal tools. So rather than the products we sell, the tools we use to make those products and to test them. And one of the big things we have to do is hardware integration testing. And so we actually have global hardware labs with thousands of machines where we can actually do daily integration tests of the entire Red Hat platform and actually make sure it actually works on all of the hardware that we say it does. And that includes mainframes, because mainframes don't get a lot of press these days. But we've been doing financial transactions and all that sort of stuff for years, long before the internet came along. And a lot of that work and a lot of that heavy lifting is actually still done by mainframes. It's not a huge market, but it's one that still exists today. And so that gets me to this question. What actually is software distribution? And so from my point of view, software distribution is anything that's involved in getting software from the people that wrote it to people that would benefit from using it. Now the internet gave us many, many more options for doing this. But the thing is, the old ways didn't go away. They're all still there. We have new options, new possibilities. And so ultimately, what it boils down to is that one easy answer to the question of what is software distribution is it's an unsolved problem. We have not actually found really, really good ways of getting software from the people who wrote it to people who can benefit from using it. We have lots and lots of different possibilities that work for different groups of people. And that's pretty much the direction it seems to be going. That this is not a problem that is possible to solve in the general case. Instead, what we have to do to make it practical, we have to constrain it in some way. We'll make language-specific packaging systems, we'll make operating system-specific packaging systems, we'll make packaging systems that are specific to a particular problem domain. We will do something to make it simpler. And then by doing that, we then create all these different systems, which we then have to make them all work together somehow. But it gets worse. The technology is the easy bit. And that's saying something. But yeah, people are really, really complicated. We actually, and so reaching users, educating users, reassuring users that this stuff will actually work for them. That's something you have to do on top of actually making the technical tools work. And so if anyone's been in marketing, this curve may be familiar. The idea of this curve is that it describes a recurring pattern in the way technologies get adopted. Way out on the right-hand side there, well, your left-hand side, we have this blue area, and that's for the innovators. These are the people who are going off in a million different directions at once, all trying out different things, seeing what works, what doesn't. And it's basically, a lot of the stuff in there, it's very, very fast moving, very, very hard to keep their attention. It's always about, that's old, that's settled, what's the next thing? After that, we get into the early adopters. These are the folks, we're looking at what are the innovators doing and saying, what out of that looks interesting? What looks like it solves a problem that matters? And we grab it and we say, does this actually work? Can we generalize this? Can we tidy it up? Can we make it more robust? Can we make it of interest to a larger group of people? And the fact is, a lot of technology falls at that barrier. That's what that chasm section is about. It's a lot of ideas, innovators come up with something, early adopters go, let's try it, and then they just go, you know what? This really isn't that good. It doesn't actually solve the problem. It claims to solve, it's not actually better than what we had before. Okay, put that one aside, move on to the next thing. But some of the things actually are good ideas, and they'll make the jump across the chasm, get into the early adopters, and then they'll get into this green section, the early majority. The early majority and the folks in the green section usually aren't interested in the technology for its own sake. They're interested in it because of what it can do for them. So innovators and early adopters, we're there because we're saying, this is cool. We actually like working on this, we're interested in it, we want to make it better. Folks in the green section, that's not what it's about. It's the phrase most associated with that section is, I just want something that works. I don't care about the details, I just want it to work. Get out of my way, let me do what I'm interested in. And so this basically chart is a big part of my life these days. And here's one of the reasons. CPython is what I consider to be the Python community's most successful product. And the reason being, it's the one that's got into that green section. And there are lots and lots of ways for people to get hold of CPython in ways that work for them. And the interesting thing about getting that broad adoption is you can't do it alone. It takes an ecosystem to get there. And that's where I'm going to start today, is talking about a bit about what that ecosystem looks like. And so obviously, Python itself is at the center. It's like, without Python, we wouldn't be here. If Guido hadn't released it 20 odd years ago now, there would be no Python community. The other logo, one other logo I've got there is the one for PyCon US. And it's the thing of, it's not just software. It's about people and community and all that sort of stuff as well. And then the last part I've got there is the Python Packaging Authority. And that's cat herder in chief. And that is about providing the tools to actually let people get access to all of the stuff that's not just CPython. So, but what are some more details of what this ecosystem looks like? That's all the PyCon logos I could readily lay my hands on. These are just the global international ones. So these are country level ones. It's not any of the US state level ones, not Python user groups, not workshops. These are just national PyCons, or regional in the case of APAC. We have PyCons on every continent except Antarctica. So, and those are just the PyCons. I'm not counting the scientific Python conferences. I'm not counting the PyData conferences. I'm not counting other open source conferences that have Python tracks. At linux.conf.au earlier this year, one of my comments on about the third day was, I am at a Linux conference, right? Not a Python one. And so really this is just the tip of a gigantic community iceberg. So, but okay, so that's conferences. But what about what people use Python for? Well, web programming and web services is a big one. And so for that, you've got things like Django is a great all-inclusive framework where you're saying, look, I don't know much about this web programming stuff. Tell me what to do. Give me a very opinionated framework that helps me learn and guides me in good directions. But the thing is, once you've reached a point of expertise, you may be going, yeah, you know what? I'm not sure I agree with all of those decisions. I'd like something that gives me more options. And then you say, well, I can go grab some Flask or grab Pyramid. I'll combine it with SQL Alchemy. Maybe I'm actually more looking for something like a CMS, and so I'll grab Plone. Or I'm looking for something that's a bit more PHP-like, and I'll grab Web2Py. Or I'm like going, yeah, I'm looking for some low-level network programming type stuff. And I'll go, oh, I'll grab Twisted, so some of the best network protocols on the planet. And you're like going, oh, but now I need somewhere to run my stuff. And you're going, well, then I'll run it on Google App Engine, which can be a little interesting at times. Or something like OpenShift, something like Heroku. Or maybe I'll go for a Python-specific provider like Gondor.io. But there's lots and lots of options for doing web programming. And lots of languages would be happy with that. Hey, yep, we're really good at web programming. Excellent. But maybe I'd like to do some data analysis. So data analysis in Python is big enough that it has its own non-profit organization. So numfocus.org, specifically focused on scientific open source ecosystem. IPython Notebook, pretty much revolutionizing a lot of the ways that numeric computing is taught. Teaching computational thinking to a whole bunch of students and as Lorena Barber puts it, if there's computational thinking, there's computational learning. And so IPython Notebook lets people learn things like mechanical engineering, aeronautical engineering in ways that lets them interact with the equations and visualize them and see what happens as they change the numbers. And so software carpentry programs, peer-to-peer education program aimed at improving the computing skills of research scientists so that they can do reproducible science, learn to use version control, learn to do task automation so they don't have to do things manually. And then the entire scientific Python stack, the PyData conferences, the SciPy conferences. So this whole world out there of data analysis that's accessible to Pythonistas because it's all in the same language. We can all communicate. But what about the next generation? Python in education. The Raspberry Pi Foundation in the UK. A lot of people think about that, oh, it's a cheap computer. It's not the point of the Raspberry Pi. The point of the Raspberry Pi is to revolutionize computing education in the UK. So that when you have computers that are that cheap, you can afford to give them to the students. You don't have to figure out how to let the students afford them. And when you're changing school curricula, one of your biggest problems is how do you teach the teachers? And that PyCademy is huge. That's the work the Raspberry Pi Foundation are doing to actually solve that in-service training problem. They've done so well with it that UNICEF, and the Lebanon-based International Education Association, they've taken a lot of the Raspberry Pi materials and they're using them to teach in refugee camps. That this is world-changing stuff. Closer to home for me anyway. In Australia, we have the National Computer Science School, which tries to teach a 5-week boot camp every year that's aimed at teaching computational skills to high school students. And then the company that grew out of that, Coghlan, Dr. James Curran, one of the leads in that whole system, is also one of the co-authors of the upcoming Australian digital curriculum. And again, strong preference towards using Python as that educational language for the next generation. In the US, we've overtaken Java as the preferred teaching language at top US computer science schools. And then you get into things like the online education, Open edX, giant Django application that people are using to host their own courseware. And then community outreach efforts, software carpentry again, Django girls, Pi ladies, all about bringing more Python to more and more people and making it a tool for empowering people to control their own world, to actually learn computers as something that they can control, not something that controls them. Now we get to my world. This is our redistributor network, or at least the bits of it that I'm personally aware of and personally paying close attention to. This is actually just a subset of it. But every community Linux distro ships Python to all their users. Commercial Linux distros ship Python to all their users. If you want to get Python for Windows, you don't have to get it from python.org. You can go to Redistributor, ActiveState, Nthought, Continue Analytics. People have lots and lots of options for getting Python in ways that are of interest to them. And this sort of stuff, this is how you get into the green sector. The folks downloading stuff from python.org, generally going to be innovators and early adopters. When you're going through a redistributor, it's usually because you want something that just works. You want somebody else to do the hard work of saying, yes, this will work for you. This will do the job. One of the interesting things is that we haven't actually historically been all that great at managing these relationships. And this is taking up a hell of a lot of time, my time these days, is improving these relationships and actually making that redistributor network be something that works for the community rather than against it. And then another huge thing that I think a lot of people don't quite realize the significance of this particular slide. And if anyone hasn't heard of OpenStack, what OpenStack is basically it's an open source framework for managing your IT infrastructure. That's at a big picture level. And so the logos on that slide, aside from the OpenStack Foundation itself, those are just the 8 platinum sponsors of the OpenStack Foundation. These are the folks that they're significant enough players that they were saying, no, they want a guaranteed board seat. If you go down the rest of the sponsor list for the OpenStack Foundation, it's basically a who's who list of the computing, network, and storage infrastructure world. Pretty much everybody's there. This is a giant turf war. Big companies battling out with each other for the future of computing. The fact that that's written in Python, that's world-changing for the Python community. And figuring out how to manage that is a huge issue for the PSF board and for the CPython core development community. This is something where we have an opportunity here. If we can divert even a fraction of the resources going into OpenStack into making the entire ecosystem better, this is a huge opportunity for us. And then just a few other little ones that I quite like that are Python in places you may not expect. Python's really big in animation. Weta Digital is sponsors for this conference. And it's because of that thing of, one of my favorite descriptions of it is an executive at an animation studio saying that the reason they like using Python is that things the programmers have to do, previously used to have to do, the animators could learn to do for themselves. And that meant the animators were happier, and it meant the developers could be free to go build even more sophisticated tools rather than having to build little utility scripts for the animators. One of the best Python IDEs on the planet is actual Microsoft Visual Studio. And that's because Microsoft actually released a Python plugin for it as open source. The full scientific Python stack. If you want that on your Apple tablet, you can go install Computable and do your data analysis on your tablet. We're big in the geosciences, geographic information systems. Data analysis, so Esri and CERN. I believe there's an interesting keynote along those lines tomorrow. And I haven't even talked about all of the Python-specific tools, things like IDEs, all the other frameworks in other application domains. But I had to include one. One of them is Python anyway. And that's really what we're aiming for here. And so, if you get anything out of that part of the talk, it's basically this idea that redistributors are not the community's enemy. We occasionally screw things up, but we're not the enemy. And so, when you're in that position of taking software written by the community for the community and commercializing it and selling it to other people, it becomes an interesting thing of how do you make sure you're dealing fairly with the community. And so, putting my Red Hat on for a moment, this is one of the things we try to deal with through our upstream first and default to open policies, that everything we sell to end users has to be available as a related open source project as well. And so if people are comfortable with open source, they want that co-developer experience rather than the customer experience, they have that option. They can get involved in the projects, they can use the projects rather than the commercial products. And that's not about altruism, it's not any kind of idealism. It's about recognizing the underlying currency of the open source community is freely available, working, documented software. It's like, that is how the ecosystem works. And people who figure that out and are willing to play by those rules, it becomes the case of the community gets more software, they get more support, they get more QA, and then we get products, we get one of the best engineering departments in the world. Because no matter how big you are, there's always going to be more smart people who don't work for you than you can ever hope to employ. And then what the community gets out of it is that we extend the reach. That it is through the redistributors that we get into that green zone. However, Python communities historically had a problem. That a lot of our redistributors, we've been focused specifically on CPython, not on the alternative interpreters, and we've often been domain specific. So for instance, if you go to a Linux distributor, we probably don't have up-to-date software for the scientific Python stack. If you go to a data analysis focused redistributor, they're probably not going to have all the networking components. And so that kind of, to my mind, creates two questions. How do we help redistributors to do a better job on behalf of the community? And how do we, as a community, handle the cases where the redistributors fall short? And these two questions are basically what the Python Packaging Authority is trying to deal with. And so this is a name that originated with the pip and virtual env developers. They wanted a name that reflected the fact that they were both developed by the same team of people. But also that they were very opinionated about what they thought good packaging practices looked like. And so they came up with the name Python Packaging Authority. And round about the time of PyCon US last year, I suggested, well, that's a pretty cool name. How about we make it a home for all of the projects that are working together to try and improve the Python packaging ecosystem? And so now at the PyPA repos on GitHub and Bitbucket, you'll find the Python packaging index itself, the wheel distribution format, the setup tools project, the Python launcher for Windows, dislib, which is a bunch of utilities for packaging, the Bandersnatch mirroring client, the Python packaging user guide, and the efforts to come up with a metadata 2.0 standard. They're all part of the PyPA ecosystem. And one of the most interesting projects I think we're working on at the moment is packaging.python.org. And so for a very, very long time, one of the biggest problems with Python packaging It wasn't that the tools didn't exist. It was that it was really, really hard to find good guidance on what the tools should be, or what the currently recommended tools were. And so what we've done with the Python Packaging Authority and the Python Packaging User Guide, it's now hosted on a python.org subdomain. In the Python world, python.org, it's pretty difficult to get more authoritative than that. But in addition to that, so packaging.python.org is where the Packaging User Guide is hosted. But pip has also been bundled with Python 3.4, so if you install Python 3.4, you should just have pip there to use. And we also have an accepted Python enhancement proposal to backport that to Python 2. So Python 2.7.9, when it comes out in a few months, should have pip with it automatically, at least on Windows and Mac OS X. Linux is a bit more complicated because Linux. However, it's not all sunshine and roses. We're basically catching up on about a decade's worth of documentation debt. And so if you want to help promote Python, one of the most useful things people can contribute in the near term is to go to packaging.python.org and look for one of the sections where Marcus Smith or I have sketched out, we want to write something about this here. Sometimes that'll just be in the form of section headings. Sometimes it'll be in the form of bullet points. But what it's not is in the form of instructions a beginner could follow. And we actually suffer from a bit of a problem here, is we've been doing this for a long time, and we sometimes forget what beginners don't know. And so actually writing this stuff ourselves will sometimes leave things out. What we can do, though, is if somebody else writes them, we can review it and say, yes, that's correct. And that will often actually result in better documentation than if we write it ourselves. So that's the thing, just explaining to people how to use the tools we already have, helping to explore the ecosystem and make it accessible. But one of the other things is helping redistributors do a better job. Because at the moment, because the thing is, people use redistributors because they like them. They like the service we provide. They want to get stuff through those channels. The problem is, a lot of the time in the open source community, we get frustrated with redistributors slowing things down, and so we go around them and say, we don't care about the people who like your stuff. We're just going to go talk to the people who want to consume stuff from upstream directly. That's great in terms of reaching the innovators and early adopters, less great in terms of reaching everyone else. And so a lot of the work we're doing in the Python Packaging Authority, and particularly around metadata 2.0, is trying to get us to a point where, at least in theory, you could push a button and automatically convert the whole of the Python packaging index to any format you want. We may not actually get there, but that's the level of ambition we're talking about here, the level of automation that we would like to make possible. And so, yeah, and that's something of interest both from the upstream packaging ecosystem side and also from the downstream redistributor side, because that impedance mismatch actually creates a lot of work. And the more we can streamline that, the more it basically benefits the entire ecosystem. And so the specific tools that are the focus of that effort are the main PyPA tools. So the Python packaging index, pip, setup tools, wheel. We learned from the distutils 2 experience that unless we have a workable transition plan, major packaging changes just don't work. And so this time around, we've taken a very different approach. We figured out what we can do that actually has a sensible transition plan that actually lets us get from the status quo of 45,000 odd packages on the Python packaging index, that we're pretty much done with a Perl-style versioning scheme of version it however you want, we'll figure out something. And so if anybody goes to read PEP 440, which is now the accepted versioning spec of an actual formally defined, this is how versioning on the Python packaging index works, you will look at it and go, what on earth is this? Why would anyone ever design a versioning system that complicated? And so what you will find is that if you have to cope with 45,000 existing packages, which were designed with a packaging scheme borrowed from CPAN, you need to interoperate with the Debian apt-based ecosystem. You need to interoperate with RPM. You need all of your file formats and file names to work on Windows, Mac OS X, and Linux. It gets interesting, and PEP 440 is the result. That said, with the work going on to integrate that into pip and setup tools, we ended up at something like 99.8% compatibility in terms of if you pip install with pip 1.6, you will get the same package that you would have got previously, except that pre-releases will be ignored, finally. So that's what we're trying to do on the upstream side. And, however, we live in a complicated world. Remember what I said earlier, the tech is the easy bit, the people are the complicated part. Redistributors serve a purpose for the community, but we're still commercial operations. What we ship and support's gonna be driven by what makes sense for us as a business. However, this is open source, so as a community, we don't have to go through the redistributors. Not always. We can provide other options. And so, when redistributors fall short, because it's gonna happen. Pip and virtual env work perfectly if you already have your Python runtime. So within a given Python installation, pip and virtual env will deal with a lot of redistributor issues. There's still some stuff around binary dependencies on Linux, and still a few issues with the scientific Python stack, but we're getting there. What they don't help with is managing and updating the Python runtime itself, and they don't help with updating external dependencies. And this is especially the case if you don't have admin rights on your machine. Yet if you look at the way Python gets used, Windows is a major market. 35 million installer downloads a year from python.org alone. So that's not counting the redistributor network. That's just directly from python.org. Wouldn't it be convenient if there was a completely open source cross-platform packaging tool that worked much the same way on Windows, Mac OS X, and Linux, could be used to manage the underlying Python runtime like any other package, could be used to manage external dependencies in any language, and can be used even if you didn't have admin access on your machine? It would be nice if such a thing existed, and so it's cool that it does. And so Conda is an open source project created and released by Continuum Analytics, specifically to deal with the complications of the scientific Python stack. The external dependencies in that domain include things like Fortran libraries. And in a lot of the open source world, there's a tendency to dismiss Fortran as, well, who uses Fortran anymore? And the thing is that in terms of high volume number crunching, Fortran is still king. It's like it is specifically built to do that really, really fast and really, really well. And so there's an awful lot of number crunching software written in Fortran that there's just no reason to rewrite it in anything else. And so if you want to do that kind of array-oriented programming, you need to be able to deal with Fortran dependencies. And so the way Conda manages this is it kind of gives up on some of the idea of integrating nicely with the redistributors. It's designed to be its own redistribution channel. And as an end user, that's sometimes what you want. You may not care about integrating nicely with your operating system, you just want the software. And so that makes Conda a really good option for people that are looking for user-level installations that are platform independent and are completely independent of the system Python. And so because Conda's not technically a Python packaging authority project, because it's not Python specific, so it doesn't make sense for it to be a PyPA project. But we do recommend it as a open source cross-platform dependency management system that was originally designed specifically with the needs of Pythonistas in mind. Now, up to here, I've mostly been talking with my Python packaging cat herder-in-chief hat on. But I also work for a Linux vendor. And so, amongst other things. And so, we recognize on the distro side that this is not just an upstream problem. We need to change the way distros work because the way people develop software has changed. And so a lot of the problems the Python community has with the way distros operate, they're not unique to Python. We hit them with all the dynamic language communities. We essentially hit them with every language community that has its own language-specific software distribution ecosystem. And the thing that happens is that developers like those language-specific or cross-platform developers like having cross-platform packaging tools. They want to be able to learn one set of tools and target any platform. And so as Linux distros, for a very long time, we resisted that. We're basically saying, no, 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 we want to make the Linux distro be an integrated whole. We don't want these isolated silos at the application layer. And basically, what I think the rise, particularly the rise of smartphones and the rise of app stores in general showed, is that we needed something more nuanced than that. We needed to be able to have a barrier at which point we handed over responsibility to the application developers and said, okay, at this boundary, this is your problem. And really, the emerging pattern is for that to be at the language runtime layer. That's where we do the handover from the distro packaging tools to the language-specific packaging tools. And so part of this is about unlocking the distro gates, making that distinction between the initial review for licensing and that the software is not actively malicious, separating that from the strict distro packaging policy requirements to say, yes, we can ship this as an integrated part of the distro and promise that it's not going to tread on anything else and that you can install it in parallel with everything else in the system. And that it's fully policy compliant and installs things in the right directories. And so that means that we really want to manage that barrier so that users get the choice. Users can either choose to use distro packaging or application-specific packaging as makes sense for them. And so one of the key things where Ubuntu blazed the trail for this was when the notion of personal package archives. The idea of making it easy for people to publish distro packages that aren't part of the distro itself. Fedora's followed suit with the Copa build system that makes it easy to publish custom repos, not just for Fedora, but also for Red Hat Enterprise Linux and CentOS and other RHEL derivatives. In Fedora 21, which is due out soon, the Fedora Playground concept aims to tie this whole notion closer into the OS itself. The idea that you have this cloud of software that is relatively easily installed, has at least been checked to not be actively malicious and to be properly licensed, but also lets you easily install it onto your system. But one of the other problems is the idea of just having one Python on your system isn't necessarily enough if you want to run Python 3 and your distro ships Python 2. Maybe you want a newer PHP, maybe you want a newer Perl, maybe you want Node.js, maybe you want a newer PostgreSQL, maybe you want a newer Apache, maybe you want Nginx. There's all of these things that are shipped as part of the operating system, but you also want to use them in applications. And so what software collections are designed to be is, for Pythonistas, I describe them as the equivalent of virtual env for the system package manager. The idea being that you're not doing isolation for security reasons, you're doing isolation for dependency management. That you want to say, no, 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 my application doesn't use the system version, it uses something else. And so on a fast-moving distro like Fedora, you may say, oh, I want to use the old one just to make sure things don't break. Whereas on a long-lived stable distribution like CentOS, you may say, no, no, I want to use something newer. So I want the stable base to build on, but for my own stuff that I'm monitoring closely, I want the latest and greatest. And again, it's that thing about developer and user choice, that letting users decide what's best for them rather than deciding for them. And so software collections are currently an RPM-specific thing. They were originally built by Red Hat for the benefit of our users. And so we're publishing them as open source because we think it's a good way to do this operating system independent runtime model in the Linux world. And in particular, it's a good way to manage this handover to the language-specific packaging tools, so that using the OS packaging to get a software collection, and then using pip to install stuff into the Python package, into the Python collection, becomes quite a good way to build applications. But it's still, again, only part of the story. Modern applications tend to be quite complicated things, especially when we're talking network services. And so there's this ever-going research and development effort in the operating system world, trying to get a version of portable execution environments that actually works for everybody. And so this is not a solved problem in general, but we keep trying different ways of achieving it. Platform as a service is one approach to this, and it works well when it is applicable, but it's very, very specific to stateless web applications. It kind of assumes there's a database somewhere that you can store all your state in. You can go to a NoSQL store that lets you do sharding, but that kind of requires that eventual consistency is okay. Virtual machines give you a lot of power and flexibility, but they're kind of heavy and you have to keep the operating system up to date. So, yeah, it gets complicated. And so this is why, if anybody has heard the word Docker in recent months, this is why everybody basically went, oh, that works nicely. Docker is one of those things where it is a project which took a bunch of things that already existed, like Linux containers and various other bits and pieces, and brought them together in a way that got the developer experience right. And so it became a case of, and they got the developer experience right well enough that a lot of people who are interested in this area went, right, we'll stop fighting, we'll pick this one as good enough. Because the benefits of standardization and working on improving a common approach outweighed any particular gripes anyone may have had with any particular aspects of the way Docker works. And they're definitely gripes. And so, as a result, Docker containers are kind of emerging as a broad de facto standard for how to do portable execution environments on Linux, and in a very lightweight way. The interesting thing about Docker, though, is it handles running the container images quite well, but it doesn't really have a lot to say about how to define them in the first place. And in the Python world, we're actually quite well positioned for this model, because we can use something like Conda to define what goes into a container in a completely distro-neutral way, or we can use something like software collections in combination with pip, or if we're happy with running in the system Python, we can just use pip itself to just install directly into the system Python in the Docker image. And so again, this is the thing that it makes cooperation between developers and operations teams a lot easier, because the developers just provide a standard unit of executable software in the form of a container that ops just have to run up and provide. And they don't really need to care what's inside there. They don't need to care whether it's Python, they don't need to care whether it's Perl or Ruby or JavaScript. They just care that it's a container that has certain external interfaces, needs certain network ports, needs certain disk access. And so it becomes a really good way of abstracting away a lot of underlying details. One actual really neat trick you can do is if you have a system, if you have a config management and automation system, what you can actually do is if you use that system to define how to build your containers, then you can have a model where you can either deploy to bare metal, you can deploy to a VM, or you can build a container and deploy that. And on the development side, you don't actually care which way it's being run in production. You can just use any of them. However, this is all very, very much an area of active research. Active research, active development. A lot of this stuff is usable today, but it can all stand to be improved, both on the Python side and on how do we use the new technologies that the distributors are coming out with. And so, yeah, it's things like filling in the rough notes on blanks on packaging.python.org, disutil sig mailing list and the PyPA communities on GitHub and Bitbucket, the Conda community on GitHub, figuring out how best to use things like software collections and Docker containers for the Python community, exploring other development models, other deployment models like the single file executables, Windows and Mac OS X installers. Can we get some more opinionated surveys of those options on packaging.python.org? Basically so that folks who are new to Python and are trying to solve these problems often don't have the knowledge they need to make sense of the vast array of options that will come back to them if they do a Google search. It becomes a thing of having an opinionated description on packaging.python.org, even if experts may find the specific recommendations arguable, at least it gives people a place to start. Whereas at the moment, the thing of, particularly people who are coming from more centralized communities, those where they may have a single central company that dominates the discussion or a single central framework that says do things this way, those communities can actually often be easier to get started with because there is a way to do it. And in Python, we've been around for long enough and we've had enough people doing enough interesting things that the one obvious way to do it at the language layer doesn't necessarily hold at the ecosystem layer. And so one of the things we're aiming to do with the Python Packaging Authority is make it easier for people to get started. To say, if you don't have an opinion of your own yet, do it this way. And then once you're experienced enough to see all of the things that are wrong with that recommendation, because software distribution is complex, there's always going to be trade-offs, then people can come back and say, hey, maybe the recommendation should be this, maybe we should explain some of these trade-offs. But this is all something that people can help with, and we need help. So I encourage people, A, look at packaging.python.org, you may learn something that you didn't know. But also, if you spot something that's missing where you know better than we do, or where we've said we don't have details here yet, help us fill it in. So thank you.
Thank you very much, Nick. We have a couple of minutes for questions. What I'd like people to do, if you have any questions, come down here, and we're going to have the microphone on the tripod for you. Or I can run around. Which would you prefer? Who said that?
I don't want to talk, I just want to see you run around.
Do we have any questions for Nick? Okay. Okay, no, I'll do it.
How do you see Python virtual environments fitting into all of this?
Yep, so Python virtual environments are actually very, very helpful if you're running in the system Python. Because what they let you do is they let you get away from that need for admin access and get that initial isolation from the operating system layer and between applications. So pretty much anywhere where I said pip in the talk, virtualenv and pyvn fit into that same space.
Hi, I'm really pleased to hear some of the things you've been saying, but, and it's a big but, how do you expect me leaning more towards ops side of things to take using the Python distribution methods seriously when there is no mechanism for notifying security updates?
Yes, I agree.
I thought you might with your Red Hat hat on.
Yeah, the notion, if you look at the talk I did at LCA, one of the reasons that upstream packaging gives ops people fits is that upstream is currently relearning all of the lessons Linux distributions learned 10 years ago. And hence my thing about feeding the distributor channels is that there are actually lessons learned there that we're still learning upstream. And the problem with it is that that's actually really time intensive. It actually takes a lot of developer effort and maintainer effort to actually just keep on top of the security issues and make sure they're dealt with promptly and notified promptly. And that kind of ongoing maintenance and attention, we haven't figured out how to do it upstream yet, just because of the sheer amount of that kind of availability and response time is one of the things that, from my point of view, you really need to pay for. And as a company, we need to figure out how to get it funded. And so there's a project called Victims. So I think the URL is victi.ms. So that's currently Java specific and focused on tracking vulnerability details for Java projects. I've spent a bunch of time talking to those folks. They are interested in expanding to other language communities, so things like Python, Ruby, that sort of stuff. It's not there yet, but we are talking to them. And I think that's a good way for us to go, to try and track it in a language independent way where people can go to this project and say whatever language they're using, they can get those updates. But yeah, it's a hard problem. And again, it's the same as similar to software distribution in general. The technology is the easy bit. The people management is the hard part. So.
Still have time for one or two more questions. While I have the microphone, I did remind you that there are dinner tickets still available if you go to registration. And apparently, I think there are a few more spots at the PyLadies lunch. So if you want to go to the PyLadies lunch and you missed out on booking for that, talk to Oren during morning tea. And there was a question up here.
So I would be interested in your take on the impact of certain libraries for Python 3 not being there, support for Python 2 being extended, but how does it influence kind of to cater for kind of these two big ecosystems in terms of packaging and taking it all forward?
So this is one of the reasons why we did the PEP to get pip bundled by default with Python 2.7, which is that a lot of the tools for migrating to Python 3 are actually on the Python packaging index. A lot of the standard library additions in Python 3 are on the Python packaging index. But Python 2 doesn't currently ship with a tool for letting you access the Python packaging index, at least at the install side. And in terms of the missing pieces in the Python 3 ecosystem for folks coming from Python 2, yeah, that's one of the big reasons why Python 2 is still supported, is that every time another project goes Python 3 enabled, that's a segment of the community that can switch to Python 3. So that's just a matter of setting them up, knocking them down. Red Hat's currently actively working on getting Fedora to Python 3 on the install images. Canonical are working on it for Ubuntu and Debian. So it's one of those interesting things where the more heavily invested somebody was in Python 2, the more dependencies they can end up having that they have to wait for before they can be Python 3 ready.
Cool. One final quick question, and then we're off to morning tea.
Hey, so my question is, you've described a very complicated kind of set of cats that you're trying to herd, and we have a very, very complicated environment that we operate in. My question is something along the lines of, if we don't do stuff, and you've described things that you want to do to make it better, what's the shelf life of the current solutions that we have? If we don't do this stuff, when does everything break and stop working?
That's a quick question.
Yeah. No. So in a lot of ways, most of this stuff for the use cases that it currently handles, it's the case of the existing use cases probably will keep working for pretty much indefinitely. It's the case of that, yeah, where you get into trouble is more in reaching new users who don't have the installed base and the existing commitment to Python, and they're evaluating it against other options. And they're like going, okay, we have a completely clean slate to start with, what do we use? And sometimes those users may not have the experience with long-term maintenance to recognize the challenges that can arise when a upstream community has a philosophy of move fast and break things. So yeah, but yeah, Python 2, it becomes the case of the reason we were able to just say, okay, we'll support it to 2020 was we're pretty sure we can get the resources to actually meet that commitment. So.
Cool. Please join me one more time in thanking Nick Coghlan for coming over from Brisbane.